Internal resistance of a cell. The internal resistance R of a cell is the opposition to the flow of current within the cell caused by its electrolyte and electrode. It results in a voltage drop inside the cell, meaning the terminal voltage V is always less than the electromotive force EMF E when current is flowing. From Ohm's law, V is equal to IR, so I is equal to V over R. The total resistance in the circuit is big R plus small r, where big R is the external resistance and small r internal resistance. Hence, the current becomes I is equal to E over big R plus small r, cross multiplying E is equal to IR plus R in bracket. Opening bracket, E is equal to IR plus IR, big R and small r. IR, terminal voltage, V is the voltage available to the external circuit, the useful voltage. IR, small r, the lost volt, small v, the voltage drop inside the cell due to its internal resistance. When current I flows through the cell, some of the cell's EMF E is used up in overcoming this internal resistance. The voltage lost inside the cell is called the lost volt and is equal to I small r. The lost volt is the voltage required to send the current through the internal resistance of the cell. So we can write E is equal to big V plus small v, where big V is equal to E minus IR. In summary, E is the electromotive force, total energy supply per coulomb. V, the terminal voltage, useful voltage across the external circuit. V, which is IR, lost volt, is the energy lost inside the cell. When a current flows through the cell, the electrolyte and the electrode resist the flow of current. This resistance causes some of the cell's energy to be converted into heat, reducing the voltage available at the terminals. As the current increases, the lost voltage increases and the terminal voltage decreases. This is why a battery may seem weak or dead when supplying a heavy load. Factors affecting internal resistance of a cell. 1. Distance between the electrode. Greater distance increases the internal resistance. 2. Surface area of the electrode. Larger electrode area decreases internal resistance. 3. Concentration of electrolyte. Higher concentrations lowers internal resistance up to an optimum point. 4. Temperature. Increasing temperature usually decreases internal resistance. 5. Age and condition of the cell. Older or deteriorated cells have higher internal resistance. Internal resistance and strength of a cell. The strength of the current obtained from a cell depends not only on its electromotive force EMF, but also on its internal resistance as already explained. To obtain a large current, the internal resistance must be low. This can be achieved by 1. Making the plate large, 2. Placing the plate close together, 3. Using an electrolyte with low resistance, high conductivity. A Daniell cell with an EMF of about 1 volt and internal resistance of about 1 to 3 ohm, if its terminals are shorted with a copper wire of negligible resistance, the maximum current obtained will be about 1 to 0.3 ampere. This is quite safe. But if a 2-volt lead cell with an internal resistance of about 0.01 ohm, if shorted with the same copper wire of negligible resistance, a current of about 200 ampere will possibly be obtained. This can cause severe damage to the cell and the wire may vaporize explosively, causing burns or injury. 12 Daniell cells connected in series have the same EMF as a 12-volt car battery. However, due to their high internal resistance, they will be quite useless for working the electric starter motor of a car. Question. A cell supplies a current of 0.5 ampere through a 4 ohm resistor and a current of 0.25 ampere through a 9 ohm resistor. Calculate the EMF and internal resistance of the cell. The first step in all electrical problems is to draw a circuit diagram. In this problem, we have two unknown, the EMF and the internal resistance of the cell. It is therefore necessary to obtain two equations which will be solved simultaneously. Given values, a 4 ohm resistor, when connected, supplies a current of 0.5 ampere. A 9 ohm resistor, when connected, supplies a current of 0.25 ampere. Let E be the EMF of the cell in volts and R the internal resistance of the cell in ohm. Using the formula I in brackets big R plus small r bracket close. Substituting in the values for the first case, E is equal to 0.5 bracket open 4 plus R bracket close, equation 1. For the second case, E is equal to 0.25 9 plus R in bracket, equation 2. Equating equation 1 and 2, since both equals E, we have 0.5 in bracket 4 plus R is equal to 0.25 in bracket 9 plus R. Opening brackets, we have 2 plus 0.5 R is equal to 2.25 plus 0.25 R. Collecting like terms, 0.5 R minus 0.25 R is equal to 2.25 minus 2. We now arrive at 0.25 R is equal to 0.25 R is equal to 1 ohm. Substituting into one of the equations to find E using equation 1, E is equal to 0.5, bracket open, 4 plus 1, bracket close. E is equal to 0.5 times 5. E is equal to 2.5 volts. Final answers: the internal resistance R is equal to 1 ohm, while the EMF E is equal to 2.5 volts. Share your thoughts with me. See you in my next class. Bye.